Okay, everyone. So today is the third lecture for the chapter 9. Let's go to page chapter 9. Let's go to page 84. So it is third lecture of chapter 9. Okay, page 40, and we did them all. 80, 84. So that is the page 84 of our slide. Okay, so today we will study the testing mean. So we calculate the sample mean. After then we have to check that this sample mean is meaningful sample or not. So we have to compare this sample mean with benchmark mean. So, but in this case, we don't know what is the population variance or population standard deviation. Unknown population variance or population standard deviation. So in the previous example, we have sigma or sigma square, population variance and population standard deviation have given. But in many cases, as we discussed in the confidence interval, population standard deviation or population variance will not be given. So more than 90% of the case, we don't have population standard deviation. So we have to use the sample standard deviations instead of population standard deviation. And we have to use the student t distribution as we studied in the confidence interval. If we don't have population standard deviation sigma is unknown, then we have to use the sample standard deviation instead of population standard deviation. And our normal assumption is not works anymore, and we have to use the student t distribution with degrees of freedom n-1. So this n is the number of samples. Okay. So in this case, so the previous example, we used the z statistics such that x bar minus mu divided by sigma square root n. But this sigma is not given, so we have to use the sigma s instead of sigma. S is the sample standard deviation. So we have to use that x bar minus mu divided by s divided by square root n. S. So instead of sigma, we have to use s. So then this statistic is not z, it is t calc. So that is t statistic. We will use the notation t instead of z. So our t statistic is sample mean minus population mean. Sample mean minus the hypothesized mean. So it is benchmark mean, benchmark value mu0 divided by s over square root n. This s is sample standard deviation. So let's study this part using the example. So this example, name of this example is hot chocolate. So one bagel shop, bagel and coffee, sells hot chocolate for the non-coffee crowd. Customer research shows that the ideal temperature of the hot chocolate is 142 Fahrenheit. So if this bagel shop provides 142 degree hot chocolate, then that is hot but not too hot. So that is perfect temperature for the customers to enjoy the hot chocolate. So customer research So choose random sample, 24 cups of hot chocolate in this bagel shop. And so check the temperature of each cups, and so gathering that information, and we obtain this data. So the first cup has 140, second cup has 140, the third has 141, 145, 143, and so on. That is the temperature of 24 sample hot chocolate cups. And the sample mean of this 24 data, is 141.375. Okay, and standard deviation of this sample is 1.99592, so almost 2. So then at significance level 10%, does this sample evidence shows that the true mean differ from 142, that is the perfect temperature for the hot chocolate, and this sample mean, if we have this sample mean, then we can believe that this bagel shop provide the perfect temperature hot chocolate to the customers. That is the question. So then, let's calculate. Let's do the hypothesis test one by one. Okay. Okay. So then first let's state the null hypothesis. The null hypothesis is that mu is 142. 142 is mu 0. Mu 0 is 142. That is benchmark value. And we believe that population mean is same as 142. That is the null hypothesis. Alternative hypothesis is that population mean is not 142. Okay. So then the mean temperature is correct. That is the null hypothesis. And the alternative hypothesis is that mean temperature is incorrect. Step 2. Specify the decision rule. Our level of significance is 10%. And if we calculate the critical value, so then it is two-tailed test. So we have to find this number, and this number, such that the right tail covers 5% and the left tail covers 5%, because our degrees of the level of significance is 10%. So here is alpha over 2, here is alpha over 2, 5%, 5%. So then we have to find this critical value. So if we consider that normal distribution, then this point would be 1.645 plus 1.645 minus 1.645. But unfortunately, we do not have the population standard deviation, so we cannot use the normal distribution. Instead of normal distribution, we have to use the t distribution with degrees of freedom 23. This 23 comes from n minus 1. And as you know, we check 24 samples in the collecting data. So degrees of freedom is 23. So if the degrees of freedom is 23, then so this two-tailed test critical value can be obtained by this Excel function. So if you check that, if you have Excel, then so if you have Excel and you'd like to know that where the critical values start, then you can use T distribution. And in this case, we use the two-tailed test. So that's why this function, name of this function has dot 2t. And x is so 10%. Our alpha, x is the alpha. Our level of significance is 10%. And degrees of freedom is 23. So then that is the critical value we would like to find. Okay. Degrees of freedom. I'm sorry. We have to use inverse. So to find the critical value, we have to use that T distribution functions, and this one is inverse cumulative distribution function, and 2T means that degrees of freedom. The test. So we are doing the two-tailed test, so that's why we have 2T. And this number is level of significance, and that is the degrees of freedom. Okay, so then we have the number 17138. So roughly 1.714. So here 1.714. So in this case, we use the two-tailed test inverse. Two-tailed test, so degrees of freedom is n-1, and we have the 24 so data. So 24 minus 1 is 23. Okay. So or if you do not have Excel, then you can use the appendix D. So please find the appendix D in the end of your textbook. So in the end of your textbook, you have the appendix D. And in this appendix D, you have this table. Okay, so T distribution table. Our level of significance is 10%. Okay? And we are doing the two-tailed test. If you do the one-tailed test, then you have to use these numbers. But here we use the two-tailed test. So, and here is 10%. I'm sorry. So then, and our degrees of freedom is 23. Our degrees of freedom is 23. So this column is 10%. significance level is 10%, and we are doing the two-tailed test. So, and we have to follow this column, and the degrees of freedom is 1.714. So degrees of freedom is 23, so we obtain that 1.714. Okay, so here we have, so here is the degrees of freedom. That is 5% because so we have this range is 5% and this range is 5%, so that's why it has 5%. But we are doing the two-tailed test, and the level of significance is 10%, so we have to check this one instead of that one. But if you use this the table which provided by this textbook, then here, so the two-tailed test 10% is one-tailed test 5%, so that's why it has this number in this slide. Okay, so that means 10%. So anyway, we obtained that 1.714. So if we select minus 1.714 and 1.714, and if our t statistic is located between these two numbers, then we do not reject the null hypothesis. But if this t statistic is located in this left tail part or right tail part or left tail part, then we reject this null hypothesis. Okay, it's the same technique as we do in the previous example. So step 3 is calculate the test statistic. Test statistic T-calc is given by this equation, and here we have to use the sample standard deviation instead of the population standard deviation, and sample standard deviation is given by this number, and it is sample mean, so that is sample mean is given by this number. Please check this sample mean and this sample standard deviation using Excel in your home. And our benchmark temperature is 142, so that is perfect temperature to enjoy the hot chocolate. And our number of samples are 24, so let's take the square root 24 and divide it. So the 1.99592 should be divided by square root 24, and then we obtain this number, and finally we obtain this minus 1.534. Okay, and make a decision. Since the test statistic lies in the range of the chance variation, we cannot reject the null hypothesis. So finally we conclude that this bagel shop provide perfect temperatured hot chocolate. Again, so here is the T distribution with degrees of freedom 23. And if our degrees of freedom is 23, then minus 1.714 and plus 1.714 covers that 5% right tail and 5% left tail. And our T statistic value is 1.5. Let me check it again. 534. So here minus 1.534, and here is 0. So this number is between these two values, so we cannot reject the null hypothesis. Okay, and so that is the conclusion. So if alpha, we are select that alpha is 10%, level of significance is 10%, and degrees of freedom is 23. If we select 5% level of significance. So then that means it is the t distribution degrees of freedom 23. And if we select the 5% level of significance, then we have to have 2.5% right tail and 2.5% left tail. So then this critical value for the 2.5% left tail and 2.5% right tail is minus 2.069 and plus 2.069 as this number. Okay, and of course our test statistic is minus 1.534, whatever. So this number is between this interval, so we don't reject this null hypothesis. But and alpha is 1%, then alpha is 1%. Okay, let's draw it again. Alpha is 1%, then here is the t statistic 23. And this part should cover that 0.5%, and this left tail should cover that 0.5%. And this number is minus 2.807, and here is plus 2.807. So our t statistic is minus 1.534. So again, this point is between this the interval. So we do not reject the null hypothesis when we select that 1% significance level. Okay. However, if we consider that 20% significance level, 20% significance level, so then that means we have the t distribution with degrees of freedom 23. So then 20% significance level means that the right tail covers 10% and left tail covers 10%. And so in this case, so let me exaggerate the graph. Sorry, let me exaggerate graph again. So here is the graph. This t distribution degrees of freedom 23, and this part covers 10% right tail, and this part covers 10% right tail, and so then this number is minus 1.319, and this number is plus 1.319, and our t-calc test statistic is located in here. So this number is minus 1.532, which is less than this number. So if our level of significance is 20%, then so critical value is minus 1.319 and plus 1.319, and our t statistic is outside of this interval, outside of this interval, significance interval. So we reject this null hypothesis for the 20% significance level. So that is the sensitivity of alpha. Okay. So be careful. If the significance level of significance is 20%, then we reject this null hypothesis. But level of significance is 10%, then we do not reject the null hypothesis. 5% don't reject. 1% don't reject. But if the significance level is high, then we have to reject this null hypothesis. So in this case, we also use the p-value. Okay? So the p-value of two-tailed test is, as we studied, p-value of two-tailed test is that probability that t statistic is less than, so absolute value minus absolute value of t-calc, or probability that t is greater than absolute value of t-calc, where t is the t distribution with degrees of freedom 23. So that is the p-value of two-tailed test. So it is absolute value of t-calc, absolute value of t-calc. So that is, since the t distribution with degrees of freedom is symmetric, so that is two times probability that t distribution is greater than absolute value of t-calc. Okay, so then our t-calc value is minus 1.534, minus 1.534, and so then we have to calculate this probability. So then probability that t statistic with degrees of freedom 23 is greater than absolute value t-calc. So then that is the probability that t degrees of freedom 23 is greater than 1.534. So then that is exactly same as 1 minus probability that t degrees of freedom 23 is less than 1.534. Okay. So then let's use the Excel function. So then t distribution. And so, 1 point t distribution, 1.534, degrees of freedom 23, and we are using the cumulative distribution, so true. So then that is 0.93066. So this probability that this let me use so we are calculating the probability that degrees of freedom, t distribution degrees of freedom is greater than 1.534. So then that is 1 minus probability that degrees of freedom 23 is less than 1.534. And we have 1 point, and we calculated by Excel, so it is 0.9306. So it is 0. So 1 minus probability that degrees of freedom is less than 1.534 is 1 minus this number is 0.931, so it is 0.069. Okay, it is 6.9%. So it is, if alpha is 10%, then that is Okay. Okay. And the p-value is 2 times probability that t distribution degrees of freedom 23 is greater than t calc, absolute value of t calc. And what we did is probability that t statistic is greater than 1.534. So that is this probability. So we do that 2 times 0.069. So this one is that one. So then we have 13.8. So percent. So that is greater than 10%, and it is greater than 5%. But this value is less than 20%. So that is p-value. So p-value is greater than 10%, so we can conclude that the null hypothesis is not rejected at 10% significance level. But this p-value is less than 20%, so we can conclude that so the null hypothesis is rejected. The null hypothesis is rejected at 20% confidence level. Again, the null hypothesis is not rejected at 10% significance level, and this null hypothesis is rejected at 20% confidence level, the significance level. Okay? So that is p-value method. So we have this number. If we do like this, so simply we can do t distribution point two-tailed test, and our x value is 1.534 and degrees of freedom is 23. So we have this number. So that is the p-value. So when you calculate p-value, you can use this function simply. So then we have this number. So this number, and so we have this number. So p-value is greater than alpha, when alpha is 10%. So then we cannot reject the null hypothesis. Okay. So I'm sorry. If we calculate the confidence interval, so then we review the confidence interval. So then here is the sample mean, and it is t statistic 5% is 1.714, and it is sample standard deviation, and that is square root the number of samples. Then we obtain the interval, confidence interval, that 141.375 minus 6.6983, and so this number plus 69.6983. So the confidence interval is again obtained by these numbers. So 140.677 and 142.073. And our null hypothesis is that mu is same as 142 at 10% significance level. So then we can draw this. That is confidence interval. The minimum value is 140.677, and the maximum value is 142.073. And our benchmark value is included in this confidence interval. So 142 is included in this confidence interval. So that's why we cannot reject the null hypothesis with 90% confidence interval. Okay? That is the relation between confidence interval and hypothesis test. Okay. And another thing is that if we use the extremely large sample, then we can use, again, normal distribution instead of t-distribution. But it is, okay. So that's it. That's all of chapter 9. So we've studied the hypothesis test with 3 videos. And chapter 9 is over. Thank you.